my name is Xiaohan, and this is my MAE ECE535 experimental demonstration project. And for this project, I would like to demonstrate wireless power transfer. As we learned in class, a voltage is induced when a conductor is in a time-varying magnetic field. And for this project, the magnetic field is generated by a primary coil driven by a 12-volt AC power supply. The magnetic flux that's generated by this coil induces a voltage in the secondary coil. So let me show you how this finished project works. As you can see, the secondary coil is not connected to any external power supply. But as I put this coil on top of this box, you can see the motor start to turn and the LEDs light up. As I turn off the power to this box, the LEDs goes off and the motor stops turning. So let's take a closer look at what's inside the box. So I have a AC power supply inside, and I have an AC power cord that's connected to the wall outlet, and that will go into our switch and a fuse panel. The reason I wanted to add this fuse panel is because I want to protect the rest of the circuit in case of a short. And from the fuse panel, we have the wires going into the transformer. And this is a 120 volt to 12 volt transformer. It's capable of outputting 3 amps. And the output of the transformer is connected to my primary coil. It's directly connected. And I have a bypass capacitor. And this coil has about 75 turns or so, and has a diameter of 12 centimeters. Alright, let's take a look at my secondary coil. My secondary coil has a similar diameter, but it has 100 turns of wires, and its terminal are connected to a rectifier, and the reason for that is because both the motors and the LEDs run on DC voltage, and I know that the voltage that's generated by the secondary coil is AC. So from the rectifier, I have 2 LEDs and a small cell phone vibrator motor connected in parallel to the output. So let me show you how it works again. And turning on the box, and you can see the LEDs light up as I move this thing around, and the LEDs will go off. The motor will still turn, but eventually the motor will also stop turning. And as I put the secondary coil directly on top of the first one, you can see that's when the LEDs are the brightest and the motor turning it the fastest. Because as I move this secondary coil around, I'm not coupling as much of the flux as I can in this situation. So this is my demonstration project. I hope you liked it, and thank you for watching.